Okay, you guys, I wanted to share a couple things about these quadrilaterals and some other facts that hopefully you guys have identified from your activity yesterday. Is that if we know something is a parallelogram, then we know that both pairs of opposite sides are parallel. That's what makes it a parallelogram. So we can use that little mark by saying this. We're going to say that those two opposite sides are parallel, and then these two opposite sides are parallel. So that's one feature of a parallelogram. The other is that both pairs of opposite sides are congruent. So this one and this one have to be congruent as much as this one and this one have to be congruent. Okay. We also know that both pairs of opposite angles are congruent. So this one and this one, those are opposite of each other. Those are going to be congruent, and that also means this one and this one are going to be congruent. Okay, so what does that make these two angles? Well, I want you guys to think about it. This is a parallel line, this is a transversal, or this is a transversal, or we could do it, vice versa with the other parallel lines, but these are considered consecutive interior angles or same side interior angles. And so since those are same side interior angles of parallel sides, we know that consecutive angles are supplementary. So however you look at it, these two guys or these two guys, if this was our parallel line and this was our transversal, these would also be consecutive interior angles. So no matter how you look at that, these guys, these two, or these two, consecutive angles are going to be supplementary. And then something that we also know about all parallelograms is that the diagonals bisect each other. So if I was going to take right here and just do a quick bisect, or do a quick diagonal, make a diagonal. Okay, so what does it mean that the diagonals bisect each other? Well, I know that this one right here and this one right here are equal to each other. And then we know the same thing here. We know that this guy and this guy are going to be equal to each other. So if they bisect each other, it's cutting those diagonals into two equal pieces. So those facts are really important in regards to parallelograms. So if we have a parallelogram, then we know that those 5 things are true. Okay, so specifically then with these other types of quadrilaterals, we could have a rectangle. And if we have a rectangle, then it has to have everything, all the attributes of a parallelogram, plus it's going to have some additional information. Well, what additional information? It's going to have all 4 90-degree angles that are all going to be congruent. So all 4 angles are 90 degrees. And then something else really interesting about the diagonals of a rectangle, and I'm going to actually draw both of these on here so that you guys can see this. Okay, so those are the 2 diagonals. We know that it's a parallelogram, so that this and this are equal because it's a parallelogram. We know this one and this one are equal because it's a parallelogram. But we also know something else is true. We know that the diagonals are actually congruent. Okay, that is not a feature of a parallelogram. So the reason why we know this one right here, okay, and this one right here are equal is I want you guys to think about Pythagorean theorem. Okay, we already know that it's a parallelogram, so we know these sides are equal. So this one and this one have to be equal. We know that these guys are equal. This one and this one are equal. So if those are equal, we basically have 2 right triangles that have the same legs. So we have a pink one and a green one. Over here, you guys can see the same thing, a pink one and a green one. So we are creating a hypotenuse that has to be the same. So the diagonals of rectangles are congruent. That is not true up here with parallelograms. Okay, so what's different about a rhombus? Well, it has all the features of a parallelogram again, okay? But then we will also know that all 4 sides are congruent. And you guys did this as you were measuring your different quadrilaterals yesterday. We also know, I want you to think about what is unique about these diagonals. So I'm going to draw these in here. Go ahead and draw them in with me. Okay, and hopefully even just drawing those, you guys can see that this is not the same distance as this, right? So it's definitely not that the diagonals are congruent. That is not going to be true. But what we do know is that the diagonals are perpendicular to each other right here. And if you guys were to take your protractor and actually measure that, you would see that with a rhombus, this is very much going to be 90 degrees in all four of those angles. That is something that is only true once we get to a rhombus. The other thing that's unique about rhombuses is that the diagonals are going to bisect the angles. So what does that mean? It means that this one and this one are equal. Well, because a rhombus is also a parallelogram, we know that this one and this one are equal. So those two things have to be the same, right? And we don't know that these guys match, but what we do know is that whatever that angle amount is, that is going to be bisected by those diagonals, okay? So that is something that's very unique about a rhombus. Okay, last thing. So a square. So a square is going to have all the characteristics of a parallelogram that we've already gone over, and it's going to have all the attributes of a rhombus. So let's just go through real quick and remind ourselves what they are. Well, all four sides have to be congruent, right? The diagonals, what do we know about the diagonals? Let's draw those in first. Okay, so we know that the diagonals are perpendicular. And we know that the diagonals bisect angles. So I'm just going to make those marks the same ones that we just did with that other rhombus, because we know that a square is also a rhombus. So a square has to be a parallelogram. It also has to be a rhombus, and it's going to have all the attributes of a rectangle. So what does that mean? Is that all four angles have to be 90 degrees. So all of those guys are going to be 90 degrees. And the diagonals, do you remember what those have to be? Those have to be equal or congruent. Okay, so that comes from the attributes of a rectangle. Okay, so we know that in a rectangle or in a square, these guys are always going to be 45, right? That's the only way, because if it had to start at 90 degrees and we know that those diagonals bisect them, they're going to be getting cut in half, and then they're going to be 45 each. Okay, so those ones are very special, right? Those types, we've got parallelograms, rectangles, rhombus, and then a square. Now, trapezoids are actually not a type of parallelogram. There's something quite different. They only have one side that is parallel. So one pair of opposite sides is parallel. So here, when you look at which of these sides are parallel, it's going to have to be this one and this one. Okay, same thing with these guys. And they don't have to always be situated like this. They could be flipped to its side, but they're only going to have one pair of opposite sides that is parallel. And then the other thing that is true about trapezoids is that the consecutive interior angles are supplementary. And why is that true? Because we have parallel lines. So this guy right here and this guy right here are going to add up to 180 degrees because they are a consecutive interior. And that's the same with these two. Okay, and that will be the same over here. These two guys added up are going to equal 180, and these two angles added up are going to equal 180 because they are consecutive interior or same side interior angles of parallel lines. Okay. There's not a whole else that we can say about trapezoids, just regular old trapezoids that look like this. We don't know anything about these two other legs, is what they're called. These are not the same distance in regular trapezoids, okay? But over here with an isosceles trapezoid, there's a lot more to it, okay? These guys are called base angles, and so these angles are going to be congruent. Okay, so base angles are congruent. Whether those two are the base on that parallel side or these two could also be congruent. Okay, I already mentioned that legs are these guys. Okay, and if we have an isosceles trapezoid, then I know that those legs are congruent. So I'm just going to make a little mark right there to say that those legs are congruent. Let's draw in those diagonals and see what you guys notice. Okay, so I want you to look at that. Does that look like the same relationship that parallelograms have? That parallelograms bisect diagonals. This amount right here is not the same distance as this, right? So this is not a parallelogram. That attribute of diagonals is not going to be true. But what is going to be true is that the diagonals are going to be congruent. Okay, so this amount, and I can even just show you with this example. So from here to here, it's just 4.6, 4.7. Okay, if you come and do the same one right here, you've got your same distance. Okay, so those diagonals are definitely going to be congruent, but the diagonals do not bisect like they do in parallelograms. Okay, so that's just something to notice. We'll talk more about this later, but one thing that you can definitely see is that the bases are considered the parallel sides. So this is base 1, base 2, or vice versa. It doesn't really matter which one is which. So the median is going to be this one that's halfway in between, and we'll talk about that later, but it just means that it's half of these two added together. Okay, and we'll talk more about that later. Okay, last one is a kite. So something unique in terms of studying all the different types of quadrilaterals is that a kite is not a parallelogram whatsoever. So it has no pairs of parallel sides. But what it does have is it has two pairs of congruent adjacent sides. So these two guys that are right next to each other, those guys are going to be congruent. And then these two guys are going to be congruent. Okay, now if we look at these diagonals, it has kind of a unique attribute. So I'm going to mark this really quickly. And hopefully you're noticing, just making the observation, is that when we do those diagonals, this is not a coincidence. Okay, with kites, that is going to happen. One of the diagonals is going to be the perpendicular bisector of the other diagonal. Okay, that will always be true. And so anytime we have these attributes of 90 degrees, you guys got to be thinking about Pythagorean theorem. Okay, we've got two legs and a hypotenuse every time. So there might be other ways that you can find missing sides. Kites are going to be symmetric. So that's one of those other features. Okay, so just in terms of a quick little summary, we have been starting to study quadrilaterals. We know that just to be a quadrilateral, it has to have four sides. We know that if we have two parallel sides, we're going to have parallelograms. Okay. If we have one set of parallel sides, it's just going to be a trapezoid. If we have no parallel sides, it could be a kite. And then in terms of parallelograms, we have different features. We could have a rectangle, okay, or we could have a rhombus. And then if we have both of those things, we're going to have a square. Okay, so I just wanted you to visually see, and I know you took these notes yesterday, but within this group of quadrilaterals, four-sided figures, we can have two parallel sides, one parallel side, or no parallel sides. If we have two sets of parallel sides, we could have rectangles or rhombus. If I have both of the features for rectangle or rhombus, then I'm also going to have a square. Okay, so what you guys are going to do is you are going to take the rest of the time to find missing information, find missing values when they tell you that this is a parallelogram. So like for something like this, so if I know that AB is 15, well, I know that this is a parallelogram, so I know that opposite sides are congruent. So I know that DC has to be 15. If I know that BC is 8, then I know AD has to be 8. Okay. If I know that 68 is angle D, well, I know that opposite angles, so angle B has to be 68 degrees. Well, how are we going to find these two pieces of information? Well, we know that consecutive interior angles are congruent. So if I do 180 minus 68, I'll get that, and then I can find out those other two pieces, okay? So that's what you guys are going to be looking at, is you need to look at the fact sheet and think about, okay, what features do I know? One little hint is when you start to come down with rectangles and rhombus and square, even with kites, if you have something with 90 degrees, you might need to be considering Pythagorean theorem, okay? So just use that, that little hint.